Welcome to MRL. This is part 2 of learning of rational numbers. In this part, we'll be learning about the methods of finding rational numbers between two rational numbers and other properties of rational numbers. So let us begin. Methods of finding rational numbers between two rational numbers. There are two different methods. One is called as the mid-value method and the other one is known as the denominator method. Now here we are trying to find out the rational numbers, required number of rational numbers between two given rational numbers. If R and S are rational numbers, then the average of R and S, that is adding R plus S divided by 2 is the average, is a rational number between R and S. So that means when I take the average of R and S, I get one rational number R plus S upon 2 between R and S. This procedure can be followed to find any number of rational numbers between two given rational numbers. So let us understand this with the help of an example. Now here we have an example to find 5 rational numbers between 2 by 3 and 8. 2 by 3 is one rational number, 8 by 1 is another rational number. Now to find the average of this, we have to add the two numbers and divide it by 2, and we get, by calculations, we get 13 by 3. And again take 13 by 3 and take 2 by 3. Now find the average of this, we will get 15 by 6. So we have taken 2 by 3 and 8, we have added, we got 13 by 3, we took 13 by 3 and took 2 by 3, we get 15 by 6. Now take 13 by 3 and add 15 by 6. 13 by 3 and add 15 by 6 and divide it by 2. We get 41 by 2. So we have 1 and 2 and 3. 3 rational numbers between 2 by 3 and 8. But we want 5. So let us take now 8 and 13 by 3. 8 and 13 by 3 divided by 2. We get 37 by 6. And take 37 by 6 and 13 by 3, add them and divide by 2, we get 21 by 4. So in all we have 1, 2, 3, 4 and 5 rational numbers between 2 by 3 and 8. It is a very easy method, although it is a lengthy method. Therefore, the 5 required rational numbers between 2 by 3 and 8 are 15 by 6, 41 by 12, 13 by 3, 21 by 4 and 37 by 6. So that is the first method of finding out rational numbers between two given rational numbers. In the second method, that is called as the denominator method. For understanding this, let us consider an example. Let us say we want to find 8 rational numbers between 2 and 3. Here 2 and 3 are two rational numbers. 2 is 2 by 1, one rational number. 3 by 1, another rational number. Now if you observe, here the denominators of 2 is 1, 3 is 1, that means denominators are same. Now for finding out 8 rational numbers, we have to multiply 2 by 9 and 3 by 9. So we get 2 into 9, 1 into 9, that is 18 by 9, 3 into 9, 1 into 9, that is 27 by 9. That means denominators are same. Therefore the required 8 rational numbers are 19 by 9, 20 by 9, 21 by 9, 22 by 9, 23 by 9, 24 by 9, 25 by 9, 26 by 9, and these are the 8 rational numbers between 2 and 3. A very simple method which is called as denominators method, and this was an example when the denominators are same. Now let us consider an example where the denominators are not same, they are different. So let us consider an example. Find 5 rational numbers between 1 by 6 and 5 by 21. Here denominators are different. So now the first step is to make the denominators same, and for that we have to find the LCM of 6 and 21. The LCM of 6 and 21 is 42. So you have to make the denominator 6 as 42. So multiply it by 7. So also multiply the numerator by 7. We get 7 by 42. 5 by 21, make the denominator 42. For that we have to multiply the numerator and denominator by 2. So we get 10 upon 42. So the denominators are same. Once the denominator becomes same, then we have to check whether we can get 5. We will not get 5 here because 7 and 10 we get only 2 rational numbers between 7 by 42 and 10 by 42. So we multiply 7 by 3 and 10 by 3. So we get 7 into 3, 21, 42 into 3, 126, 10 into 3, 30, 42 into 3, 126. Now in between 21 30 we get the required number of rational numbers, that is 5 rational numbers. So therefore the required rational numbers between 1 by 6 and 5 by 21 are 22 by 126, 23 by 126, 24 by 126, 25 by 126 and 26 by 126. Further we can continue, but we require only 5 rational numbers in this. Now the next important topic of our discussion is the operations on rational numbers. When I say operations, very simple, fundamental mathematical operations are addition, subtraction, multiplication and division. So let us begin with the addition of rational numbers. Now when we add two rational numbers, we get again a rational number. The addition is very simple. Here the denominators are same, just we have to add the numerators. So minus 5 plus 6 divided by 7 is 1 by 7, which is 100% a rational number. Therefore addition of two rational numbers when the denominators are same is very simple. Add the numerators and get the answer 1 by 7. Now we can even continue, we can add using a number line. Now on this number line we have minus 5 by 7 on the left side and 6 by 7 on the right side. So now take minus 5 by 7 first. So jump towards minus 5 by 7. From there jump 6 steps. 1, 2, 3, 4, 5 and 6. We get 1 by 7. Same as we follow the rules in addition of integers. Procedure is the same. Only the difference is this number line is a number line of rational numbers. Now addition with different denominators. When the denominators are different, here 5 is different, 5 and 7 are different. So the first step is make the denominator same. 5 into 7, finding LCM, 7 5s are 35. Find the equivalent rational numbers by 5 into 7 is 35, 4 into 7 is minus 28, 7 5s are 35, minus 6 5s are 30. So we have the same denominator 35. So add the numerators, minus 28 minus 30 becomes minus 58 by 35. So that is how the addition of rational numbers is done. The procedure is followed. Now if the rational numbers, if they are mixed fractions like this, then 3 into 2 by 4, addition of minus 6 3 by 2 plus 4 into 1 divided by minus 6, it is mixed. They are mixed fractions. First simplify them, make them improper, that is 4 3 is 12 to the 14 by 4, minus 6 to 12, minus 15 by 2, minus 24, minus 25 by 6. Now add them. Now 4 to 6 are different, denominators are different, so make the denominator same, that is 12, because LCM of 4 to 6 is 12. Now 4 into 3 is 12, 14 into 3 is 42, 2 into 6 is 12, 15 into 6 is minus 90, 6 into 2 is 12, and therefore minus 25 into 2 is 50. Add them, so simplify them, add the sum the numerator, then we get 42 minus 140, which is minus 98 by 12 or minus 49 by 6, and convert into a mixed fraction. That is how we add the rational numbers. Subtraction of rational numbers is again a very simple procedure. Supposing we have p by q one rational number, r by s is another rational number. Now to add that, find the p by q, take the additive inverse of r by s, that is minus r by s, then add it. Procedure of addition is followed and we get the subtraction of rational numbers. So subtraction of rational numbers is nothing but addition of rational numbers by changing or writing the additive inverse of the subtrahend. So adding of additive inverse of r by s, that is the procedure. Now let us consider an example. 3 by 5 minus 5 by 7. It is nothing but addition of additive inverse of 5 by 7, that is minus 5 by 7. Procedure of addition is followed. Make the denominator same, 35, 5 7s are 35, 5 7s are 35, 3 7s are 21, 7 5s are 35, minus 5 into 5 is minus 25. Add, follow the procedure of addition of integers. 21 minus 25, that is minus 4 by 35, is the subtraction of the two numbers 3 by 5 and minus 5 by 7, which are the rational numbers there. Now multiplication of rational numbers is again a simple procedure. P by q into r by s, multiply the denominators q into s, multiply the numerators p into r, so the product is p into r divided by q into s. So multiply the numerators and denominators and further simplify the rational number which we have got, so that we get in its simplest form. Now for example, 7 by 11 into minus 121 by 14. So multiply 7 into minus 121, 11 into 14, we can simplify here. 11 on the 11, 11 on the 121, 7 on the 7 to the 14, we get minus 11 by 2 or nothing but minus 5 and a half. Another example here, minus 55 by 6 into minus 36 by minus 44 becomes minus 55 by 6, minus divided by minus becomes plus 36 by 44. That means if you simplify it, as we have learned how to cancel the numerator and denominator of fractions, simplify it, minus 15 by 2 becomes minus 7 and a half. Now division of rational numbers. To understand the division of rational numbers, we should know as to what is the reciprocal or multiplicative inverse. If P by Q is a rational number and Q by P is its reciprocal. Please understand, P by Q is the rational number and Q by P is its reciprocal. Means we write the numerator as the denominator and denominator as the numerator here. So P by Q is the rational number, Q by P is its reciprocal. When we take the product is always 1. Always remember, Q by P is the reciprocal of P by Q, P by Q is the reciprocal of Q by P. The product of the given rational number and its reciprocal is always 1. Now, if P by Q and R by S are two rational numbers, then P by Q when divided by R by S, we have to take the reciprocal of R by S, changing the division sign to multiplication. So therefore, the division process converts into multiplication by taking the reciprocal of R by S, that is S by R. So when we multiply the reciprocal of the divisor, we get the product, and that is the division of one rational number with another. Let us take an example. Minus 27 by 24 is a rational number. It has to be divided by minus 18 by 24. Now convert the division into what you call multiplication by taking the reciprocal of minus 18 by 24, that is minus 27 by 24 into 24 by minus 18. When we simplify, we get plus 3 by 2. So that is what is the procedure followed. Now another example, 3 by 2 plus 7 by 4 is one group of rational numbers, and divided by minus 9 by 16, minus 1 by 4, another group of rational numbers. So first of all, solve the bracket following the BODMAS principle. We have to apply the BODMAS here. So 3 by 2, the denominators are different, so therefore we have to take the LCM of 4 and 2, that is 4. So 2 to the 4, 3 to the 6, 4, then 4 on the 4, 7 on the 7, add the numerators here, we get 13 by 4. Similarly here, 16 and 4, LCM is 16. Then we have 16 on the 16 minus 9 on the 9, 4 for the 16 minus 4, add, we get minus 13 by 16. Now division has to be converted into multiplication by taking the reciprocal of the divisor, that is 16 by minus 13, 13 and 13 will cancel, and by simplification we get minus 4. So that is what is the procedure followed, and therefore when we want to carry out the operations on rational numbers, we have to follow the rules of addition, subtraction, multiplication, division, and also the sign rules of integers, and apply the rules of fractions, apply BODMAS so as to get the simplified version of the rational numbers. Now next important topic of our discussion is properties of rational numbers. Now already we have learned about these properties in natural numbers, whole numbers and integers, and all these properties, the properties of integers, as you know, integers are a subset of rational numbers, so all the properties of integers are also closed for a set of rational numbers. But again I have considered here, let us consider as to how these properties are applicable to rational numbers by taking examples. The first important property is the closure property of addition. Addition of rational numbers is a rational number. That means when two rational numbers are added, if we get a rational number, that means the property of that closure property of addition is closed for a set of rational numbers. Let us take an example. 4 by 7 is a rational number, minus 3 by 5 is another rational number, and when we add, we get minus 1 by 35, which is again a rational number. The procedure of addition is followed here. Therefore, closure property of addition is closed for a set of rational numbers. That means when we add two rational numbers, if we get again a rational number, then closure property of addition is closed, and which is true in this case. Now closure property of multiplication. The product of two rational numbers is again a rational number, therefore closure property of multiplication is closed for a set of rational numbers. For example, minus 3 by 5 into minus 7 by 2, we get 21 upon 10, which is again a rational number, therefore closure property of multiplication is closed for a set of rational numbers. Now associative property of addition. Now what is the associative property of addition? When I add B and C to A, and sum of A plus B to C, I get LHS is equal to RHS. That means associative property of addition. Now rational numbers also can be grouped and added in any order. Now for example, you take half 4 by 5 and minus 6 by 7. Let us add 4 by 5 and minus 6 by 7 and then add to half. So I follow the rules of addition of rational numbers and I get 31 by 70. And instead of adding 4 by 5 and minus 6 by 7, let me add half and 4 by 5 first and then add minus 6 by 7 to it. Then we get, by following the rules of addition, again we get 31 upon 70. That means LHS is equal to RHS, and therefore associative property of addition is closed for a set of rational numbers. Now let us take associative property of multiplication. If A, B, C are rational numbers, then B into C when multiplied to A or A into B when multiplied to C, the answer is the same, the value is the same, LHS is equal to RHS. Therefore, rational numbers can be grouped and multiplied in any order, but the result is the same. Now let us take an example. If I consider the three rational numbers 2 by 3, 7 by 8 and 11 by 13 and multiply 7 by 8 and 11 by 13 first and then 2 by 3, I get, following the multiplication procedure, we get 2 by 3 into 7 by 77 by 140, 77 by 156. So also when I multiply the first two rational numbers with the third, again I get 77 by 156. Therefore associative property of multiplication is also closed for a set of rational numbers. Yeah, come.